All right, we're going to go ahead and start with our next unit, Unit 2, Polynomial and Rational Functions, beginning with 2.1, Quadratic Functions and Models. So first of all, we have this definition, which I'm sure you've seen, polynomial function. This is a function of the following form, okay, where you have a sub n, which is our a sub nth term, times x to the power of n, plus the next term, times x to the power of n minus 1, where this power is just going down by 1 as we go on and on and on. As we get to the end, you're going to end up with x squared, x to the first power, which we actually don't write, and then x to the 0, again, which we do not write because x to the 0 would just be our 1. Okay, so it'll be in this format. We're going to focus mostly on the quadratic ones today. Here we have a few more parts of this definition where n is a non-negative integer, meaning that these powers are all positive, okay, and they are whole numbers, so 1, 2, 3, 4, and so forth. And our eighth term, so this number in front, the coefficients in front, are real numbers. So these can be any real number, just depending on the problem. One condition is that a sub n cannot equal to 0, and the reason that is so is because if we have a 0 here, that's going to make this whole thing just 0 with the multiplication. Finally, polynomial function of x with degree n is going to be how we name this. And we'll get to some examples here below. So in example 1, we're going to just classify it by degrees and name it by its polynomial name. So for letter A, we have y is equal to 2x plus 1. We can see that our highest degree here is going to come from this x, okay? And there's that imaginary 1 right here. So this polynomial function is actually a linear function, okay, with degree 1 because of that power right there, okay? Second one, letter B, y equals 9 minus 1/4 x squared. This one's a little bit out of order, but what you want to do is go ahead and reorder it. So we're going to go ahead and switch this around to like so. Negative 1/4 x squared plus 9, just so we can have it from ascending order, so the biggest degree to the smallest one. And now from here, we can see that the degree is going to be 2. And since it's an x squared, this is a quadratic polynomial. So quadratic degree 2. Okay. Next one, we have letter C. This one has 3 parentheses, so I'm not actually going to multiply it out. I'm just going to kind of explain that if we were to multiply this out to give us our form like the one up here, okay, the one we wrote up here, we would have 3 x's, or something like this, x cubed plus, and then so forth, so forth. So just with that x cubed, I know that this is going to be a cubic function. And with that 3, I know it's going to be a degree 3. Okay? All right. Next definition. We have a quadratic function is a function f of x is equal to ax squared plus bx plus c, where these letters in front represent real numbers. So these can be any real number. And I went ahead and included some notation. I didn't mention it up there, but this notation here, A, B, C, belongs to the real numbers. It's a shorter way of saying all of this. So I'm going to start using this just so we get used to it and we don't have to maybe write so much, okay? Such that A is not equal to 0. Again, if this is equal to 0, this would be gone and we're left with a linear function, which we don't want. We want a quadratic, okay? A lot of this stuff is going to be stuff you already know. We have that the graph is called a parabola, so it's like that U-looking thing, and it's symmetric to a line called the axis of symmetry, or AOS for short. This is also known as the axis of the parabola. In case you do see that verbiage, it means the same thing. Okay? This line will also cross the vertex of the graph. So here we have two different versions of what you might see with the parabola. We have the parabola that's going upward. Okay, so you can see the concavity is upward because it's positive. When this happens, our a, which is the leading coefficient, will be greater than 0. In other words, it'll be positive. So if it's positive, the graph is going up. Our axis of symmetry, which is this dotted line here, or AOS, is the line that goes right through the middle, it goes through the vertex. So once you find the axis of symmetry, you actually have the x value for the vertex as well. For the other one over here, we have our -1. So you can see the graph is going downward, and our leading coefficient would be negative, meaning A is going to be negative here, and the concavity is downward. Just like the one before, the AOS is right through the middle, and the vertex is going through this point. So here we have another example, and now what we're going to be doing is actually sketching some of these parabolas. Prior to this, I kind of gave you a little like slope type of hint on sketching them. That was more of an approximation. Okay, so right here, we're going to actually be a little bit more detailed on the accuracy of where these points lie. And we're going to do that by using a table. Okay, so this is assuming when B and C are both equal to 0, meaning you only have the A parameter to work with. So let's go ahead and look at the first part. We have f of x is equal to 1/3 x squared. We have our table and we have a graph. This part might not be given, but you want to go ahead and construct it to help you graph this. Before I do anything at all, I am going to graph my OG. Remember, that's our original graph. So based on the way I drew my lines here, okay, it might be a little bit crooked, but I'm just going to kind of sketch it. So it looks something like that. My parent function, remember this is y equals x squared. And the reason I'm doing that is because I want to compare this guy to my original graph here. So let's go ahead and find some points for this graph here. When x is equal to -2, that's going to be the same as 1/3 times -2 square. Okay, doing that in our head really quickly. -2 square is 4. 4 times 1/3 is 4/3, or 1 and 1/3. So the point here would be -2 comma, I'm going to do 1.3, just to kind of leave it a little bit easier for us to see. Okay, hopefully I don't make any mistakes. For the next one, and actually I think I'm going to use a different color because it's kind of hard to see. For -1, we do the same thing. So 1/3 times -1 square. Okay, it's going to be -1 square is 1. 1 times a third is just a third. So that's going to be 0.3, repeating, of course. Probably should put that up here also. Okay, next one, we have 0. 0 times anything is going to be 0, so that one's easy. 0 comma 0. And since this is symmetric, these should be the same as these, but we can check it real quick. We have 1/3 times 1 square. Again, 1 square is 1. 1 times 1/3 is 1/3, so 0.3. So 1 and 0.3. So far, so good. And finally, 1/3 times 2 square. So 2 square is 4. 4 times a third is 1 and 1/3, or 1.3333 forever. Okay, so those are some point values. I went ahead and just did a few so I can get a more or less idea of where this graph is at. So first point, -2, 1.3 is going to be about, let's see, about right here or so. And I'm just kind of estimating these points. Okay, -1.3 is really close to the axis, maybe right here. 0, 0 is right on par with the original. Then I have 1.3, so it should be kind of symmetric across the y-axis here. And 2, 1.3, so again, symmetric. So we have something kind of like this. And if you remember our previous chapter, we did go over something called transformations. We can see that our new graph, which is f of x, so this is f of x right here, our new graph is a lot wider than the original, which makes sense because this is in fact a vertical shrink compared to our OG. Vertical shrink means that if I were to get, this pen and squish it vertically, okay, it would be getting kind of flatter. So think of the parabola, I'm squishing it vertically, so that's why it's opening up like this, looking a little bit broader, okay? So just to kind of recall that, we have a vertical shrink or compression, whatever word you prefer, okay, by 1/3. Okay, next one. Hopefully this is kind of review. Letter B, we have h of x is equal to negative 4x squared. So we'll do the same thing. We're going to go ahead and plot our OG first. So we have 0, 0, 1, 1, negative 1, negative 1. And there is our original graph. I think this one's a little bit nicer than the other one. I'm just going to put OG here. And I'm going to go ahead and find my other points over here for this new function h of x. So we have negative 4 times, oh, that's a worse color. Let's just go back to the other one. So negative 4 times negative 2 squared, okay? Negative 2 squared is 4. 4 times negative 4 is going to give me negative 16. Oh, I might have to adjust this graph a bit. Okay, so negative 2, negative 16. Then I have negative 4 times negative 1 squared. Negative 1 squared is 1. 1 times negative 4 is negative 4. So negative 1, negative 4. 0 again is going to give me 0 everywhere because 0 times anything is 0. That one's easy. Then we have negative 4 times 1 squared, which is going to be 1 squared is 1. 1 times negative 4 is negative 4. So far we're good to go with these two. Okay. And last but not least, we have 2. So negative 4 times 2 squared. 2 squared is 16. I'm sorry, 2 squared is 4. 4 times negative 4 is negative 16. It's a good thing I caught that early. And there we go. Okay. Plot the points. I might not plot these because they're kind of, I don't think I have room here, but I'm going to plot the other ones. So 0, 0 is in the middle, negative 1, negative 4. So 1, 2, 3, 4, somewhere here. 1, negative 4, so somewhere on the other side. And then 2, negative 16, and negative 2, 16 are way down here somewhere. So I'm just going to pretend that they're down there because I did not make that many little marks here. But it's something like this. Okay. And we can see based on our new function, so h of x, that this one is not only reflected downward, but it's also thinner than the original. And that makes sense because this is a vertical stretch by 4. Okay, so for my transformations here, I'm going to go ahead and just kind of squish them in right here. We have a vertical stretch by 4, okay, and a reflection over the x-axis. So a lot of people like to ask, well, wouldn't the vertical stretch be by negative 4? I mean, I guess you can technically say it is by negative 4 because that includes the reflection. But just to be a little bit more accurate with our transformation terminology, we want to include that negative as part of the reflection, okay? And that's pretty much it for these two. So pretty basic stuff, guys. And of course, you can always check this with a graphing calculator. Just do make sure that you do have a little bit of work showing how you got from here to here, okay? All right, so this part is a little bit ambiguous, I'd like to say, because we are not used to seeing standard form in this way. So take a moment to copy this while I explain. Our textbook calls this form right here standard form. We have called it vertex form. For the sake of keeping consistency with our text, we're going to go ahead and just call it standard form because we don't want any confusion, especially with the homework problem. So there's no inconsistencies. Okay, so this is what's going to be known as standard form. From the standard form of a quadratic, we can get the vertex, we can get our axis of symmetry, we can tell whether the graph is going up or where it's going down. Okay, so all of these items can be found from this graph. So for instance, the vertex, okay, which is our HK, can be found from here and here just by looking at them. You used to learn in the past that usually this part is the opposite of whatever you see, and this is the same. That's one way to think about it. Remember from our previous lesson that this minus here is the reason why this becomes the opposite, okay? Our axis of symmetry, well, that is the line that goes right through the vertex, so it's just the same as your h. So this would be whatever you get from here, okay? If a is positive, so if this guy is positive, the graph is going to be going up. And if it's going up, that means that it has a lowest point, which is our minimum, okay? Also our vertex HK. If this is negative, so if A is less than 0 right here, well, it just means the opposite. It means it's concave down, and it looks something like this, which means we have a maximum point. And of course, the HK is still there for the vertex. just some definition stuff. Let's go ahead and try an example now on how to get from our original quadratic form to this standard form here. Fair warning, this example might be a little bit new for some of you. So up here at the top, we have a method review because I do not know if you have seen this or not. So if you have never seen completing the square before, okay, this is going to be completely brand new for you. I went ahead and outlined the steps very step by step just to kind of help with the process. This problem is asking us to go ahead and sketch the graph of this function, f of x equals 2x squared plus 8x plus 7. We have to identify the vertex and the axis of symmetry. Now, if you had a calculator, we could do this no problem. You could just graph it and trace it, right? But we're going to do it by hand because that is what I'm going to require you to do. So to do this, to go from this form to our standard form, remember the one that we just went over, we have to do something that's called completing the square. What this will do is it will transform this into a perfect square so we can write it in that standard form that we just saw. And from that standard form, we can find the vertex and we can find the axis of symmetry. Okay, so let's go ahead and start this with the steps. Step number 1 is to set equal to 0, and I would definitely write these steps down. So we're going to set this whole thing equal to 0. So it will look like the following. 0 equals 2x squared plus 8x plus 7. So easy enough. Just replace f of x with 0. Okay. Step number 2, this is where it gets a little tricky. If a is not equal to 1, we have to divide by that number because otherwise we won't be able to complete the square as nicely. So in this case, our a is equal to 2. So I'm going to put kind of here in parentheses, a is equal to 2, okay, for this step right here. That's coming from right here. So we are going to have to divide it out, okay? And it says, but hold on to it. In other words, we're not quite done with that 2 yet. So I have 0 equals 2x squared. I'm just going step by step here. Plus 8x plus 7. And I'm going to go ahead and divide everything by 2. Because remember, if you do something to one side, you got to do it to the other side also. The great thing about 0 is if 0 divided by 2 is still 0. So that's just a 0. We're left with x squared plus 4x plus 7 over 2. Okay, so moving on to step number 3. Sorry about the paper. I had to erase some things here. So for step number 3, we're going to go ahead and move the constant c to the other side. You can see here I kind of already circled it. This is our constant, this 7 over 2 that we found in step 2. So all I'm going to do is I'm going to subtract 7 over 2 from both sides. So let me go ahead and just show that in steps here. So 0 is equal to x squared plus 4x plus 7 over 2. And we're just going to subtract that 7 over 2 from both sides, like so. 0 minus 7 over 2 is still negative 7 over 2, okay, equals x squared plus 4x because those guys are gone. And we're going to leave it as a fraction because later it's going to help us, okay? Moving on to step number 4, and this is the most important step, I would have to say. Step number 4 is to add b over 2 squared to both sides. So this is where we get our complete the square name from. And this is from whatever the current equation is. So in this case, our b would be that 4 right here. Okay, so b over 2 squared is going to be equal to, in this case, 4 divided by 2 squared, which is equal to 4 divided by 2 is 2. Okay, so we square 2, 2 squares, 2 times 2, which is just 4. So I'm going to add 4 to both sides of this equation. All right, so on this side, we're going to have negative 7 over 2. Sorry, I had to white this out a bit. Finally got some white out here. Negative 7 over 2, okay, plus the 4. So there's that 4 that I was talking about, is equal to all this. So x squared plus 4x and then plus 4 again. So all we're doing is we're adding that 4 to both sides. And that's our -7 right here, in case you can't see it. Okay, that's this guy right here. Okay, moving on to step number 5. This one is just to combine and factor. So what I'm going to do is I'm going to rewrite what I have. -7/2 plus 4 is equal to x squared plus 4x plus 4. I'm going to combine this side and I'm going to factor the right side. As a side note here, in case you forgot, okay, we are going to have to change this 4 here to a fraction. So here's some side work. Remember that 4 is the same as 4/1. To get a denominator of 2, we're just going to multiply both the numerator and the denominator by 2, which gives us 8/2. Okay, so this is just -7/2 plus 8/2 equal to all this. So this is the same for now. We add the numerator, so -7 plus 8 is +1. +1. I'm just full of mistakes today. So we have 1/2, okay? That's a 1, is equal to all this. So over here on this side, what we're going to do is we're going to factor this. So if you did this correctly, this should be a perfect square trinomial. Okay, meaning I can factor it into two parentheses that are exactly the same. In this case, would be 2 plus 2 and 2 because 2 times 2 is 4 and 2 plus 2 is 4. Okay, I'm going to rewrite this one more time. So 1/2 is equal to x plus 2 squared. And this should start looking a little bit familiar because you can see we kind of sort of have our standard form happening. We just got to move this guy over here, okay? And that is step 6. So for step number 6, we're going to move the new constant, which would be our 1/2, okay, to the other side. So 1/2 is equal to x plus 2 squared. I'm going to subtract the half from this side and from the right side, and that will get rid of it for me on the left side. So now I have 0 equals x plus 2 squared minus 1/2. And we are almost done. Let me move this a bit. Okay, we have one more step, and then we're going to go ahead and sketch our graph. So since we did have an a that we had to work with in the beginning, we're going to have to multiply that back in now. Okay, so remember that our a was equal to, I believe it was 2. Yeah, it was 2 from the way top. Okay, so we're going to multiply that 2 times this whole thing. So 0 equals x plus 2 squared minus 1/2. Okay, so all we have to do really is distribute, which I'm going to show in a bit. So 2 times 0, 2 times this parentheses here, and 2 times that -1/2. And that is going to give me the following. 2 times 0 is just going to give me, sorry, I keep moving that. It's just 0, okay? 2 times all of this, the great thing about this is I can go ahead and just put it in the front, like so, because you can see that it actually becomes a vertical stretch at that point. And then 2 times 1/2, you're thinking 2 halves give me 1, so minus 1. And we are basically done. I'm just going to change this back to my f of x. Try to get this all on the screen okay here. So we have f of x is equal to 2 times x plus 2 squared minus 1. And this would be our standard form that we were looking for. Okay, from here, I can go ahead and find the vertex. Okay, so the vertex, oh, this is moving really bad. Sorry about that, guys. Here, let me just do this. Let me move this out of the way because I think that's getting in the way. So from here, we can get our vertex straight from this part right here. So from here and from here, we know that our vertex is going to be -2, comma, -1. Because remember the vertex is usually the opposite of whatever's in here and the same as whatever's on the outside. Okay, and then straight from here, we can get our axis of symmetry. because it's just the same as whatever the x value is here. So x equals -2. Okay, here on this side, I'm going to go ahead and do a really little quick sketch. So -2, -1 is our vertex. My a from the way beginning, way at the top, was positive, and actually here you can see it again. A is 2 and a is positive, so since a is greater than 0, okay, this is going to be going upward. And we're just sketching it, so I'm not going to worry about the other points. I mostly just want to make sure you have this vertex, you have the concavity correct. Remember, concavity is just up or down. And last but not least, I want the AOS, which is x is equal to -2. So right down the middle right there, x equals -2. Okay, and that concludes this part of the video. There's going to be a couple more examples in the next one. It shouldn't be too long.